Welcome to Otisam Mathematics. In this video, we are to solve summation from k is equal to 2 up to infinity of 2 raised to the power p minus k, all equal to square root of 1 plus 3 times 2 raised to the power p minus 2. So let's see how we are going to do this. Now, first of all, you should be able to expand the left hand side and see the pattern, the type of sequence. So expanding the left hand side, we have, so you start from k is equal to 2, so you have 2 to the power p minus 2 plus 2 to the power p minus 3 plus 2 to the power p minus 4 plus up to infinity. They are all equal to square root of 1 plus 3 times to the power p minus 2. Now this is geometric progression, the sequence, and is up to infinity. So for geometric sequence which is up to infinity, we find the sum to infinity. Now the formula for finding the sum to infinity is a on 1 minus r. That's the first term over 1 minus r. R is the common ratio. So from the sequence, the first term is p power p minus 2, and then the common ratio be r is equal to 1 on 2. Now how do you get a common ratio? This divided by that. That is p on 3 on 2. So this is indices. So 2p minus 3 minus p plus 2. So which is 2 to the power minus 1. Now substituting these values in the equation, we have the first term is 2 raised to the power p minus 2 on 1 minus 1 over 2. This will be equal to square root of 1 plus 3 times 2 raised to the power p minus 2. So simplifying this, we have p 2 raised to the power p minus 2 on 1 minus half is half, which is equal to square root of 1 plus 3 times 2 raised to the power p minus 2. So on the left hand side is the same as 2 raised to the power p minus 2 times, when we simplify here, we get to square root of 1 plus 3 times 2 raised to the power p minus 2. So by indices, the left hand side will be equal to 2 raised to the power p minus 2 plus 1, which is equal to square root of 1 plus 3 times 2 to the power p minus 2. So left hand side is equal to minus 2 plus 1. So we have 2 raised to the power p minus 1, which is equal to square root of 1 plus 3 times 2 to the power p minus 2. Now you should bear in mind that we want to find p, so there's a square root on the right hand side. So let's square both. So we are going to have 2 raised to the power 2 times p minus 1, which is equal to 1 plus 8 times 2p minus 2. So the square took care of the square root. So then we have 2 raised to the power 2p minus 2, which is equal to 1 plus 3 times 2 raised to the power p minus 2. So by indices, we can rewrite this as 2 raised to the power 2p times 2 raised to the power minus 2, which is equal to 1 plus 3 times 2p minus. So we have 2, we can rewrite this as 2p all squared over, and this will come down, making 4 equal to 1 plus 3 times 2 raised to the power p times 2 raised to the power minus 2. So we can have 2 raised to the power p all squared over 4, which is equal to, and this, the right hand side will be 1 plus, this will be 4, 3 over 4 times 2 raised to the power p. And we can send the rest to the right hand side. So we have 2p all squared over 4 minus 3 on 4 times 2 raised to the power p minus 1. So we can make substitution. Or first of all, let's multiply through by 4. So when we do that, we are going to get 2 raised to the power p all squared minus 3 times 2 raised to the power p minus 4 is equal to 0. So let a be equal to 2 raised to the power p. If that is the case, we are going to have a squared minus 3a minus 4 is equal to 0. So factorizing this, we are going to have 1 times minus 4 is minus 4. So the factors will be minus 4 and then 1. So a squared minus 4a plus a minus 4 is equal to 0. So a bracket a minus 4 plus 1 a minus 4 equal to 0. So we have a minus 4 in one bracket and then a plus 1 in another bracket equal to 0. This implies that a minus 4 is equal to 0 implies a is equal to 4. Then a plus 1 is equal to 0 implies that a is equal to minus 1. But we were asked to find p, not a. So for a is equal to 4, we have 2 raised to the power p is equal to 4. So 2 raised to the power p equal to 2 raised to the power 2. Therefore, for a is equal to minus 1. 2 raised to the power p equal to minus 1. Now with this, we don't have a solution, real solution. So there's no real solution for this one. So hence, the value of p is equal to 2. Thank you very much, viewers, for always watching my videos. See you another time.